Okay, so this is lesson 10. Specific heat capacity, again, you might say to yourself, didn't we do that last lesson? Well, in this lesson, what we're going to do is we are going to look at a required practical. Okay, now these are practicals you are supposed to work through. Maybe you might have to be doing some of these from the moment from videos if we're not in classrooms. But required practicals, you need to understand how to do the practical. And this is about measuring specific heat capacity, usually of an aluminium block. So what we're going to do today then is we're going to say, okay, without looking back in your book, maybe you won't be able to share this with your neighbour depending on if you're doing this remotely or in a socially distanced classroom. But anyway, let's see if we can define, without looking back in our book, what specific heat capacity is. Now, even if you can't do B, you can do C, you can check back in your book and write it back out if you weren't correct. It's really helpful if you can rote learn this definition. Okay, so specific heat capacity of a substance is the amount of energy required to raise the temperature of 1 kilogram by 1 degree Celsius. Okay, rewrite it out if you got it wrong. All right then, so here's a question. If you take a pizza from an oven, why is the cheese topping more likely to burn you than the crust, even though if you've taken them out of the oven at the same time, which obviously you have if it's a piece of pizza, so they're going to be the same temperature, so why is the cheese more likely to burn you than the crust? Like, why is the filling of a pie more likely to burn you than the pastry itself? Think carefully what this lesson's about. Okay, and that'll be because the fat in the cheese, or the cheese itself, can store more energy than the crust because it has a higher specific heat capacity. So it might have taken a little bit longer, a little bit more energy to get up to the same temperature. Okay, but then because it's got a higher specific heat capacity, it has stored more energy. All right, so this is what we're planning to do today then. We're going to look at how we calculate specific heat capacity. We can use a joule meter because we have to calculate the energy we put in, or we can use voltmeters, ammeters, and a clock to do the same thing to calculate the energy, and we'll go through the steps for that. So just to remind ourselves then, specific heat capacity, energy transferred by heating, divided by the mass of a substance multiplied by the temperature change. Okay, and that's what it looks like in the formula triangle, so make sure you've got that down in your book from last lesson. So this is the first required practical for physics, and this is how many you have in total. So there you go, you've got 10 required practicals to cover in the course of your physics GCSE. Now, not everybody has to cover 10, only if you're doing separate sciences. There's a couple that you don't have to do if you're doing the combined course. So I think what we'll do today is we'll go straight to 2 videos. This guy is Miss Stabler's favourite presenter, and there's an alternative here. So this is how you do the practical if you haven't got access to the equipment. So it'd be worth you pausing the video, this video, going off onto the PowerPoint that comes with this lesson, and clicking on the links and watching through. So you do need to make notes on this. So it's worth watching both because you need to know how are they doing this, how are they measuring the specific heat capacity, what do they need to know. Now at the end of the videos, so you can pause now and go off and watch it, and then we'll talk about what happens at the end of the videos in just a second. Okay, welcome back. So at the end of the videos you will find these sheets. We call them the yellow sheets because we usually print them out on yellow paper, and these will be attached to the lesson or will have been printed out for you, hopefully. And then there is a complete method at the start, and then there are various other ones. This is an incomplete method, so now you've watched the videos, perhaps you could have a go at filling in the incomplete method. There's one also that has mistakes in it, so then you can go back and identify the mistakes, that sort of thing. Alright, so that would be a really good thing to do. Now, this is a picture that you'll have seen on the video of what the apparatus looks like. So we've got a block here with a thermometer in one of the holes. You usually put a drop of water into there to make a good contact with the surrounding block, and this is our heater, which in this case is connected up to an ammeter. Now at this point you won't have done P2, the electrical circuits topic. So this ammeter here measures the current flowing around the circuit, and it has to be connected into the circuit. Okay, we'll have a 12-volt supply here that's just not drawn in, but is specified because you've got the 12V there, and the voltmeter goes around that, and that measures the potential difference. Okay, so if you are using a joule meter instead of having the voltmeter and the ammeter, then you can have a joule meter here which either records the numbers digitally. Full-fuzz joule meters, the old ones anyway, used to flash 100 every time 100 joules of energy had been supplied. So you need to count how many times it flashes and then multiply it by 100 at the end. Okay, so if you're using the voltmeter and ammeter, you multiply the result from the ammeter and the voltmeter together to get the power, and then you multiply that by the time that the device was on for to give you the energy supplied. Okay, so 3 key questions would be: describe what specific heat capacity is, how would you check if your data was reproducible, and explain why having insulation around the metal block will lead to a more accurate value. So those are 3 really good questions there. Okay, so first of all, describing what heat specific heat capacity is the energy required to cause an increase of temperature of 1 degree C for a mass of 1 kilogram. And how would you check if your data was reproducible? You compare it with other groups' results. Compare the other group's results to your own and see if they are similar. If they're not, then your data wasn't reproducible. That's other groups doing the same experiment as you did. Okay? All right. Here is an example set of data calculated using a joule meter. So this was the starting temperature of aluminium, starting temperature of water, temperature when the heater was switched off, and then the temperature will carry on rising a little bit more. They both got to 36 degrees here. And then the final reading on the joule meter, so this took a lot more energy to put in. That would fit with what we know about water, wouldn't it? It has a very high specific heat capacity. Okay, so a typical exam question would ask you to draw a label diagram to explain how the apparatus should be used. Okay, so what would that look like? Here we go. Here is our answer. So this one wouldn't score full marks because it's not been fully labelled, but here is the sort of diagram that you would need to draw. So an aluminium block with insulation around it. Think back to the earlier question we had asked there about why is the insulation important. We've got a thermometer to measure the temperature, and we've got our heater here to supply energy in the first place. Okay, and then either a voltmeter, an ammeter and a clock, and in the correct positions. So this is connected into the circuit in series, and this is connected in parallel across the power pack there. Okay, or we have a joule meter connected to the immersion heater. Okay, so over to our third question then. Explain how having the insulation around the metal block will lead to a more accurate value, because more of the energy is going to where we wanted it to go, which was to heat the block, and it won't be lost to the surroundings. If you lose more energy to the surroundings, then you're going to have to put more energy in to change the temperature, so you'd get a higher value for specific heat capacity than the true value actually is. Alright, here's an example of different specific heat capacities for different materials. What I strongly suggest you do now is go back and look at the yellow sheets to have a go at filling those in. Remember, you can always refer back to the videos if you're not sure about how to do something.